All right, let's get started. Welcome to the session on refactoring to functional style. My name is Venkat Subramaniam. We're going to talk about taking some examples in imperative style and then working our way through to functional style. I'll talk a little bit about the motivations for doing this, some of the things we need to be concerned about, and then we'll jump into some examples and start looking at a few examples of how we can do this. And along the way, we'll talk about some approaches we could take. So one of the things to consider is a lot of mainstream languages, in fact, most of the mainstream languages that we've been using for the past 20 to 30 years have been promoting imperative style of programming. In imperative style of programming, we talk about how to do, but we also proceed to write code to express how to do it. So imperative style focuses on both what and how, and it's the how that really gets us into trouble because it leads to accidental complexity. What declarative programming, we focus on saying what to do, but not as much on how to do it. Well, functional style inherently is declarative in style. Not all declarative code is functional, but all functional code is actually declarative. That is one of the most charming features of programming in functional style, is that we can focus on the what and let underlying libraries take care of how to actually do it. But one of the challenges with Java 8 is, unlike the previous versions of Java 8 was not about syntactical change. It's actually a paradigm shift. It requires us to think very differently and program very differently. And I'll be honest about this. I spent several decades programming in imperative style. I can tell you that I spent my youth programming in imperative style. That tells you that I had a terrible childhood. And now I'm trying to recover from that and start programming in functional style, and it's not natural for me. I have to think really extra hard to think in functional style. And I have to say that I'm probably about a 50% level into it now. If you throw a problem at me, maybe 50% of the time I can think functionally. The other 50% I have to struggle. One of the most interesting experience was on a flight not too long ago. It was a cross-Atlantic flight. It took about 9 hours of flight. I started with the problem in the beginning of the flight and struggled with it for 7 hours trying to write it in functional style. I'll tell you, it beats any in-flight entertainment you can have. And then when I was done with it, it was like, wow, why did I have so much difficulty doing this? Because hindsight is 20/20. Once I had the solution at the end of the 7 hours, it was like, why did I have so much trouble? And what was really making it hard for me is my background, my comfort level really makes it hard for me to think differently. So that's what I want to focus on, the paradigm shift, how we can approach this maybe in a way that can make things a little bit easier for us as we consider shifting to functional style. I'm not recommending taking existing code and changing them all to functional style. I want to make that very clear. I believe in producing value. So if there's good code working, just leave it like the way it is for now. But when you come down to fix a bug, make an enhancement, or you're trying to revamp major parts of it, that's a really good time for us to revisit and maybe change the code. But also, as we sit down to write code, we can clearly write it very quickly, imperatively, the new code, but then maybe transform it to functional style. That's a really good way to learn as well as we get very comfortable with this style of programming. So let's get into some exercises and play with some examples here. I want to start with the very first example. I'm going to focus on 5 different examples in this presentation, given the time. So let's see what we can do first. I'm going to start with an imperative style of programming code to begin with. Well, I mentioned that imperative style is where we say what to do, but also we say how to do it. Let's take a look at an example real quick here. I have a little function here on the main that's looping through and telling whether the numbers 1 through 7 are prime numbers or not. Well, they say never refactor code that doesn't work. Well, this seems to be working. Ideally, I would have automated tests for it, but in this case, this is good enough for what we do here. So in this case, of course, it's working and giving us the result. But here is the isPrime method. I've not tried to be very smart about this method. I'm not trying to make it very efficient. Just take a very simple looping. I say for, and then of course I loop through this for loop, ask if a number is divisible by that range of numbers. If so, I set the variable divisible, and then I exit out of it. Now, if you look at this, this is a very reminiscent of a lot of stuff we do. Folks, there are some chairs in the front. If you want to just walk through the front, please feel free to do that. So there's a lot of seats in the front over here. And if there's a seat next to you, just raise your hand so it's easier for people to locate as well. Thank you very much, appreciate it. Okay, so let's look at this code for a second and see what it really says. Well, I have a challenge for you. When you go back to work on Monday, do this for me. Do a quick grep on for in your source code. and be scary how many for loops we use. This is like somebody knocks on the door, you open the door, there's a guy with a hammer. You ask him what he's there for, he says, I'm here to fix your kitchen. You say, are you not going to use any tools? He says, I got a hammer, I don't need any other stinking tools. You probably will let this guy in and go out and call the cops. It's not safe to be in the house anymore, right? Well, that's what we've been doing. We've been using this for hammer for everything we do. And it's insane that everything is for and occasionally a while loop that we use. But in this case, what did we do? We loop through and then check for a condition and then set the Boolean to be divisible to be true, and then we have to control the looping. But let's put this in English. What are we really doing? Well, why should we put it in English? The reason I put it in English is it really makes us to think about what we are doing, and that can help us to capture the essence of the what, and then we can look for methods that actually translates English to code. So let's see what we are doing. Given a number, we want to find the range of numbers so that no value in the range divides the given number. So that's a little formulation that can actually help us to think about it a little bit better. So let's give it a try and see how we can rewrite this code in more of a functional style. So I'm going to start importing, in this case, java.util, let's say, .stream.star. And I said range of numbers. Well, the word range immediately prompts us to think about an int stream. So I'm going to go ahead and call this as int stream. So we'll say return number is greater than 1 and int stream.range from 2 to the given number. Well, notice the for loop went from 2 to 1 less than the number. That's exactly what range does as well. It goes from the number 2 up to number -1. Range closed will include number, but range doesn't. So we have the range of numbers. Let's again go back to English. I say that given a number, the no number in the given range divides the given number. Well, in other words, nothing matches our divisibility criteria, and the method we are looking for here is called none match. And then given a number in the range, number mod I that we are interested is equal to 0. So that code in the top that you saw here translates to a very small piece of code in the bottom. I mentioned that we have been using the for hammer a lot in the past. But this one is using very specialized methods, little methods, little tools. It's like you hear a knock on the door again, you open the door, there's a guy with a little bag, and you ask him what he's there for to fix the kitchen. He lays out the tools, and you say, wow, look at that, there's a little wrench, there's a little screwdriver, there's a little chisel. Well, those are the tools of his trade, right? You ask him, are you going to use all of those tools? He says the one who uses all the tools is called a consultant. No, I'm going to use only what makes sense for the project. And the point really is we're going to use these little specialized tools to get our work done. And that's exactly what the range function and the none match function are going to do for us. As you can see, the result of that code is exactly the same as before. But what we did was we translated that fluffy code in front of us into something very highly expressive. I'm not looking for code that is short. That is not the objective. What I want is code that is concise but also very expressive. That is what I'm really after. You take much less effort to read this code and understand. Once we know what range and none match means, of course, that becomes a lot easier to work with. So that is an example of how we can use some of these ideas to create a little function that can tell us whether a number is prime, but more so to really iterate over the range of values and get the result we are looking for. So that's less noise, no garbage variables. The divisible was a garbage variable. We're not introducing unnecessary variables here. And of course, we used higher order functions. We're passing a function to the function, which is the none match function. So that really helped us quite a bit here. Let's go on to a next example here. Again from imperative, but in this case, we're going to go to a functional style of code. And I want to know how many lines in my text contains a certain word. Now, in order to do this, how would we write the code for it in the traditional Java? Let's take a look at an example here. So I have a little main function, as you can see here, and this main function starts up and first of all opens up a buffered reader and connects to a file reader, as you can see. And it's opening up my etc host file. I'm interested in searching for the word localhost, and I want to know how many lines contain the word localhost. So what am I doing here? I first of all create a line and set it to null, and we all know that null is a smell. And then we go ahead and say, while line is equal to buffered reader.readLine is not equal to null. It's code like this we should never show to children, because the minute they look at it, they say, heck, I never will be in this profession again, and they do something else. They would rather be accountants than doing this, right? So the point really is, and not that it's bad to be accountants by any means though, but I would rather be writing clear and concise code. So the point really in this case is, I really don't want to be really writing code. This is clumsy and so imperative and noisy. Then what do? We check if lines contains that particular word, and then we increment the count again, and then we keep looping through it. That's a lot of ceremony in our code. And when we are done finally, we declare the win and report the word occurs that many times in the file. Well, so how do we really work through this very differently? This is one of the things that really excites me about Java 8 is they just didn't deliver lambdas and walk away. They then took a very decisive approach to enhancing the JDK to improve all the different methods that can be really functional in nature. So let's see what I'm going to do here now. I'm going to take this code right here, and let's go ahead and comment this code out for just a minute so we can actually refactor it. And I've called this variable as count. So I'm going to say long count is equal to, but how am I going to find the count of this? Well, the very first thing I'm going to do here is I'm going to go ahead and import a java.nio.file. And then in this case, I'm going to use the class, which is the files class. In fact, let's take a little bit of baby steps to come to it. So pardon me, let's go ahead and run this first before we try to modify this. So I'll come back to this in just a second. And then, of course, when I go back and run this, we do want to make sure the result is actually the same. It said occurred 3 times. I want the same result when I'm done with this. Great. Now let's go back here and just comment out this piece of code for a second. And let's take a bit of a baby step in getting towards this. Let's go ahead and bring in java.nio.file.star. And in this case, let's go ahead and say over here, files and then lines. And then this is going to be the lines method. And this takes a path.get. And I'm interested in the path to what is the file I'm interested in. Well, that's the path I'm interested in, so I'll use the path variable right here. And so I'm going to ask it to give me the path of that particular code. That's what I'm asking for. So paths.get, so what does that really give us? Let's quickly take a look at what this function returns to us. And thankfully, what this is doing is it's returning to us a stream, which is really nice. So now that we have a stream on our hand, we can use the stream API to do further processing. So what I'm going to do now is, now that I have all the lines in the file, I'll say filter over here, and then I will say, given a line that is given to me, I'll say line.contains, exactly the code that we did right here, but we cut through all that other fluff by now, and then we ask for the search word we are interested in. And that really gives us the number, all the lines that meet the criteria, and then we set that to a count, and then now, of course, we can simply say long count is equal to, and then we can set that into that variable right off the bat right there. And then so when we run this code now, we can see that it gives us the same result as before, but we didn't have to put in so much effort to do this. So the lines method of files gives us really nicely the ability to get a stream out of this and process it, so we can again get rid of all that ceremony in the code, and we can use a functional style of coding for this. So lines gives us a stream, and given the stream, we get all the lines that meet this criteria, whatever that criteria is, and in the end, we do a count of it and get the result out of it, and that's exactly what we did in this example. So that's another way to look at it. So we saw the none match in the int stream. Now we are looking at files in the lines in the files class itself, and these are all helping us to get our work done a little bit more effectively. Once again, no explicit variables. We're using the stream and the filter method to accomplish our job in this case. Let's go a little further now. Things can get really ugly when we try to do a little bit more complex things. We're going to look at a fairly verbose code to do something really simple. This is when you realize the problem is simple, but the solution becomes overly complex, and that's when you know we are heading in the wrong direction. You don't want the solution to be more complex than the problem really we have. That would be the accidental complexity. Let's look at one example of this to see what this really means. So I have a little main here with these scores, as you can see right here. What this course is doing is it's putting a bunch of names and score values into this map. So we got people's name potentially and score values. But what I want to really do is print out who all have a common score. So let's go ahead and run this code to take a look at it. Tom and Nancy have a score of 11. Jack is the sole person with 12. Darla, Nick, and Jill have a score of 15. But the question is, how do we really do this? In the imperative style, you can just imagine how much effort we're going to put to do this. You first create a map, of course, with the score values and a list of names. That's where the trouble starts, isn't it? Then you get one score value. Does this exist in the map already? No, it doesn't. Create an empty list. Insert the empty list. Insert the name into the... Anybody wants to do that? Absolutely ridiculous, isn't it? But that's the kind of code we've been writing for years, where this simply sucks the life out of us as we start writing this code. In fact, very smart developers never write this code. We hire interns to do this stuff. And that's why this becomes really tedious to work on, and it's not fun at all doing something like this over time. So what can we do to improve this? It is insane because remember what functional style does. You tell what to do, and you let underlying libraries figure out how to do it. So you can look at all these lines in front of us, about 10 lines of code is going to just disappear in front of our eyes within seconds right now. So let's go back over here to this little code right here, and then grab the entire function, comment that out, and then what we're going to do is return. Well, we're going to start with the scores that's coming in as an input right here. So we're going to start with the scores right here. But we're going to say, in this case, key set, and I'm going to simply get the key set from this particular scores, and then again ask for a stream out of it. Then we're going to ask a collect. Now, before I go further into the collect, I want to spend a few seconds talking about one thing that is very, very important, which is called the collectors. If you have not had a chance to, I highly recommend you spend a Friday evening with collectors. Your night would be wonderful, I promise you. Because collectors is such a wealth in the JDK. I keep discovering the power of collectors time and again. And there are so many wonderful methods within collectors. And it's one of those APIs that's as powerful as anything else could be. And so it gives you a lot of these APIs or convenience methods to do certain operations on collecting things. So collectors is one of my most favorite classes, utility classes in the JDK. So I'm going to come down to the collect method, and I'm going to say grouping by, in this case, given a particular person's name, I want to group the values based on scores.get the name, or get the scores of the name itself. And you can see how the result is exactly like what you just saw earlier. But of course, some of you are not too happy because I wrote too much code here. We'll reduce it even further now. So I can now say, take this one and say, well, okay, we can actually make use of method references in Java 8. So we can take this one and say, scores :get, and we can write it much more concisely as well. So why write more code than necessary? And you can see this. So if you ever want to get into a competition, ask one of your colleagues to write that code, and while they're still starting up, you can write this code and eat their lunch. So that is one of the beautiful things about how concise this is, and it's pretty insane how powerful this is. You're saying, given all the scores, get me their key set, and then go through an iteration on the streams, using the streams on the key set, and then just start grouping them based on the score values for those names, and that's, we turned those 10 lines of code into, some will argue, 3 lines of code, but I always argue because there was only one semicolon, that's just 1 line of code. So that's basically how concise it is that you can actually make it very powerful, as we can see. That's yet again a wonderful things we can do with the library of functions available to us, which is pretty darn nice. So the code is very highly expressive. It's very declarative in nature. But of course, in this case, we use some very specialized functions. And that is something that's going to take a little bit of time and getting used to, because when it comes to some of these functions, we do have to take the time to figure out what functions are available. So there are 2 approaches I think we should kind of take to understand this. One is, when you formulate the problem in English, you can go back and ask the question, is there functions I know of that kind of matches these kinds of actions, and you can do this. The other thing I normally do is, everybody has only limited amount of ability to remember things. We can't remember everything, unfortunately. But as I kind of walk through the JDK, as I walk through libraries, as I just browse through the documentation, I would come across methods I probably have never seen, and immediately I would take a note of it. I would just pause for a minute and take a look at it and say, hey, what in the world it is doing? And it's just in the back of my mind. And another day when I'm working on something else, I might say, oh yeah, I remember seeing that little method back then. And then I would go look at it at that time, or I would put it away for maybe experimentation over maybe a free time that week, and I would play with some of those methods to see what they do, and that just becomes part of your vocabulary as you program it. Just like the groups by method, one of my other favorite methods is a method that can help us to split a collection into a couple of different things. For example, I was giving a talk recently, and when somebody said, hey, I understand filter very clearly. If I have a collection, I can filter out maybe only objects of a certain value. Let's say for a minute, just as a crude example, if I want to separate this room into two parts, I want people who are older than me and people who are younger than me. Well, that would be a filter. If I say only people younger than me would be a filter, and what that collection would have is people younger than me. But what if I really want two collections, those younger than me and those older than me? Well, filter will not help you with that. But the beauty of that is you can actually use, in that case, a partition by method. And a partition by will give you this collection, a map, which is going to have one part, which is, in this example, people younger than me, and the other part who are older than me, for example. So you can use some things like that very nicely to achieve this. Let's look at one other thing. This example, actually, I have to say, was actually inspired by somebody who attended my previous talk. They attended the talk and they emailed me and said, hey, I came to your talk, really excited to see this, but my problem is, here is what I'm trying to do, and I can't figure out from the examples you gave me how in the world to achieve this. So I really thanked the person for the question, gave an answer, and I kind of said, that's a great example, so I'm going to replace one of my examples to use this particular example. So let's take a look at what this person wanted me to work with. So here is a little example of Euclid's algorithm, and all this is doing is, given numbers, it wants to give you a collection of numbers where the property that a square plus b square is equal to c square. So for example, give me all the numbers for which this property of a square plus b square equal to c square is met. And if, for example, when I run this code, you will see 3, 4, and 5 meet the criteria. 3 square plus 4 square is equal to 25, which is 5 square. So A, B, and C are 3, 4, and 5, and so on. That's an infinite number of numbers you could actually look for, but the person wanted me to show how to solve this problem. The gentleman actually sent me the code in the imperative style and said, hey, I could do it this way. I've got a function called getTriple. To make things a little easier, we're just returning a string here. So getTriple is simply returning the A, B, and C values for which this criteria is being met, and that's Euclid's algorithm to do this. But I want all the numbers up to a certain number, let's say. So in this case, you notice what I have is a very traditional code. We start with a for loop on m going from 2 to m plus 1, and then, of course, m equal to 2 to all the way up, incrementing by m, incrementing m. And n, of course, starts with 1, but falls one short of m in that sequence. And then we go call the getTriple for m and n, and then we add it to the triple, we increase the count, and if the count is greater than the number of values we expected, then we break out of the loop. And then, of course, this is really sad, isn't it? You have to do this check one more time. This is how imperative code punishes you twice. And so you have to really check again as well, and then you break out of it and return the triples. So the question is, how do you really do this? Notice that we have 2 for loops in this code, and that's a bit confusing. How do I deal with 2 for loops? I know how to deal with 1 for loop. I can use a range method, I can use a filter, I can use a stream, I could use a map. But here I have 2 for loops. How in the world do I deal with it? Well, to understand this, I'm going to take a slightly different example to illustrate how we would work with this. So imagine just for a minute, I have a collection of person. Take example of people in this room. We got wonderful people in this room. So I have people in the room. So I have a collection of people with me. And what I want is every person has a function called get a primary email. So everyone in this room has an email, a primary email. I'm sorry, I don't want you, but I want your email address so I can spam you. What a great idea. So how do I do this? Well, the function here is a one-to-one mapping, meaning given a person, you get an email of the person. So what do you use for that? You say people.map, and then you say person, and you can say person.getPrimary email, and that's basically how you would do this in your code, so you can get the primary email very nicely. So that works really well, as you can see. However, on the other hand, if I have another function which is get all email addresses, let's just say all emails, this is going to return a collection of all your email addresses. Some of you may have one email address, some of you may have two, some of you may have 7. I mean, it's so much fun to spam all the addresses, not just one of them, isn't it? So I want to map people to all their email addresses. Sadly, this is a one-to-many because I go from a person to get email, all emails, and so this is emails, not email anymore. If I said people, a person, or people rather, dot map, given a person, person dot get all emails, well, what do you get as a result? You go from a collection of person, so this is a collection of person on one hand, so collection of person to collection of list of email. Hey, that's not probably what I want. If that's what I want, we got a winner. But that's not what I want. What I really want is a collection of person to collection of emails. So I want really the collection of all the emails, one single list. How would I go about doing that? Let's draw some inspiration from Groovy for this because Java doesn't quite have it. So in Groovy, I'm going to say a list of, let's say, 1, 2, but I'm going to say 3, 4, and then let's say 5, and let's go ahead and say 6, 7, and let's say 8 over here. I want to know how many elements I have. So I'm going to say list.size to get the number of elements, and it tells me I've got 6 elements. We know we have 6 elements, but we actually have 8 elements, but we have a list of lists on our hand. So the 1 and 2 are one element, 3, 4 is 1, 5 is the fourth one, and 5, 6 combined, or 6, 7 combined is 1. But I really don't want those collection of collection. I want a flat out one single collection. How do I really get it? So if you notice over here, that's the list of lists I have on my hand. But instead, I'm going to say list.flatten, and then I'm going to say .size, and now notice in this case, when I flatten it out, the value that I get is 8 on my hand. Well, likewise, if I just print out the flattened collection, it is a flattened collection, one single collection, not a collection of collection. So flattening is a function available in quite a number of different languages. Java quite doesn't have it. But the good news is, while Java doesn't have a function to flatten list, it does have a way to flatten streams, well, almost. So what we really want to do is we want to perform a map operation. Let's go back to the example we saw a minute ago. So we want to perform a map operation, but while we perform the map operation, we also want to flatten it. Technically, you could have called it map flatten, but that doesn't sound too well. So it sounds like a tongue twister. So they called it flat map. So now you know what a flat map is. Use a flat map when you have a collection of collection. In other words, when you have a one-to-many relationship, your candidate most likely is a flat map. That's how my mind is wired to think about it. Anytime I have a one-to-one transformation, I use a map. If I have a one-to-many transformation, I ask the question, maybe it's an occasion to use a flat map in this particular case. Let's take a look at how we can benefit from flat map in this particular case, in this particular example. So let's go over here to the code we are dealing with. Notice we have this collection of collections, but if you really think about it, what is this collection yielding? This inner loop is yielding a collection, which is the triples, and we want to put those collections into one flat collection. That's what we are trying to do. Let's go ahead and run the code real quick. 3, 4, 5, 8, 6, 10. We want the same output when we are done, but how do we go about doing just that? Once again, let's highlight all that code. Let's rewrite this in functional style. So we're going to say return, in this case, stream dot iterate, and we start with the value 2. Why are we starting with 2? Because this loop started with the value of 2, as you can see here. But notice there was no ending for this particular list. In this case, it came through the break elsewhere. That's exactly what we're going to do. Given an element E, give me an element E plus 1. This is called an infinite stream. So infinite streams have no bounds at all. We can keep on going. And so as a result, we start with 2, and then 2 plus 1 is 3, 3 plus 1 is 4, 4 plus 1 is 5, and so on. We keep going. Of course, it's lazy. It's not going to do it until we ask for data, so it's on demand. So the next thing I'm going to do with this one is I'm going to call flat map on this one. And in this case, I'm going to say, given a value of m, I'm going to now say int stream dot range, and I'm going to start with the range. Remember what this went from. It went from n is 1, but 1 shy of m. Hey, that's easy. I can start with m at 1 and go 1 shy of m readily. So that gives me the for loop for the range of values. But what am I going to do? I'm going to say map over here to object, and that is because instream expects to return an integer, but I'm going to return an object in this case. And so in this case, what am I going to map over to? This is a value of n, but I'm going to return get triple of the value, which is going to be whatever the m and n were. So m comma n, that gives us the value from here. So this is going to return to us a stream from this particular object. We're not done with this, of course, but the last step here is limit. And we're going to limit this to the number of values we expected, and then followed by, again, our wonderful collector comes in, and we're going to use the collectors, and then collectors toList method in this case. So we are going to say here is the toList method to put this back all into a list eventually. So where is the instream coming from? Let's go ahead and say this instream is coming from the stream. So in this case, that's the code we are ending up with, is to simply loop through and print all the values. So you can see again, the code is very functional and easy, but the trick here was to use a flat map in this case. Knowing that we are dealing with a one-to-many relationship, a flat map will flatten the list and give us the result eventually, and that's exactly what we did in this particular example. So that gives us an idea about how we can do this pretty effectively using a flat map. I do have to say that flat map is one of the charming features in functional programming, and I kind of keep discovering problems where flat map becomes useful. I traditionally get emails at least once a week from somebody who says, how do I solve this problem? And my brain is like, is this yet another flat map question? And invariably it turns to be at least one every week, where people are still struggling to really get a grasp of this flat map. The last thing I want to show you here is, one thing is a very common problem, but can become really annoying to solve over time. Let's actually solve this by hand and see how painful this can become. So I'll take this problem here, and then we will try to implement it and see how really weird our life becomes when we are trying to do this in functional imperative style. So let's get rid of all of this. Let's get to the main function real quick. And in the main function, what I'm going to do is try to implement the code for this. Find the sum of square root of k prime numbers starting with n. Let's say n is equal to, let's throw a number 43. And then let's say int k equals to 241, let's say, some random numbers. But how do I implement this code to compute the sum of square root of all the k numbers? Well, let's give it a try. We can say int index is equal to n, int count is equal to 0, and then we could say double result. So double result is equal to 0. When we are done with it, we want to print the result after all. But what did we do so far? Absolutely nothing useful. We just created a bunch of these garbage variables. That's what we did. And then, of course, what's our next step? We're going to then say while. And then what do we do after this? We say while count is less than k, and your brain comes to a screeching halt with the question, is it less than or equal to? Do you ever ask that question? Every single time. There's only one purpose of code like this, to make us feel stupid. Because every time you write this, you halt and say, huh? And then you're trying to find out, is it limit or limit plus 1? And this is the most vexing thing. We've been doing this over and over. And every day, this is like going to work and beating ourselves in our head, right? Because we can never get this straight. It's always confusing. And we always kind of write it and wonder, did I get it right? So it's very vexing, as you can see. Then what do? And then I'm going to ask him prime numbers. Well, okay, I can write the function for is prime very easily. So public static, let's say Boolean, in this case is prime int, let's say number. Hey, that should be fairly easy to do after all. So we can simply say return number is greater than 1 and int stream dot range from 2 to the number, and then we'll simply say none match, and then given a number I, number mod I is equal to 0. Hey, that's really as simple as that. That's what we did in the beginning example, so we can just bring that in. Well, now that we did that, what's the next step? I'm going to say if the given number is a prime, so it is index. If it's prime, then what am I going to do? Result is plus equal to math.square root of the value index and do the work. Is this correct? No, I hear people saying, nodding their head saying, no, it's not correct. What am I missing? I have to increment the index, isn't it? Now is it correct? I see we have to increment the count, so I increment the count. Now is it correct? It has to be outside, isn't it? So the count, how do you feel about that? Where the index count should be here, the count should be incremented here, but the index should be here. This is accidental complexity, isn't it? That's a lot of work to write this code. And of course, the question is, does it work? Well, we can only be in good faith, run this and see what it does. It gave us some result. But that's a lot of work to write that simple piece of code. Shall we try this again? Let's go ahead and try this one more time. Well, we can leverage our infinite stream here as well. So we can go back to this code and say, double result is equal to stream dot iterate, and we are interested from the number n, given an element, give me element plus 1, so we can start iterating from the stream. This is called an infinite stream, like I mentioned. Lambdas make it possible to create infinite streams. This infinite stream has absolutely no bounds. I know what you're thinking. If it's infinite, how long does it go? It really goes to infinity. Oh my goodness, if it's infinity, where would you store it? On the cloud, of course. But the point really is, it is absolutely infinite in size, isn't it? So in this case, of course, it's going to yield results as and when you request for the result. But then we can go to this and say, dot filter sample is prime, and we are asking for the prime numbers only. But then we can say map, well, in this case, we can say map to double, and given a value, give me the square root of the value. Then we can say dot limit. In this case, we'll say k. The question is it less than k, less than or equal to k? It's k, damn it, keep moving. You don't have to waste your time on such trivial things, and then you perform the sum operation on it. Now look at the code below compared to the code in the top. The code in the top is filled with accidental complexity. The code in the bottom removes all those accidental complexity very nicely, as we can see. We don't have to put in so much effort at all. So all we are doing here is we are iterating through all the values starting from n, lazily of course. We get all the prime numbers from n. We get the square root of all the prime numbers from n. And then finally, of course, what we are doing here is extracting only k values out of it. Well, every single one of these highlighted code are lazy operations. They don't do eagerly, including limit. It doesn't do things eagerly at all. And then the sum being the terminal operation is the one that triggers the execution. In the case of streams, it's always the tail that wags the dog. Until you have the terminal method, the engine of streams would not start kicking in, so that waits until that point to start really ticking. So in this case, of course, the beauty of this approach is, look at the code in the top. This is what I call as accidental complexity. I have a little challenge for you. Put this code in front of somebody and ask them to read it and sit in front of them and watch their eyeball. Their eyeball does this, and then it does this, and then it is shaking here. That's called the point of confusion. You're still trying to figure out what this code is doing, right? And if a business analyst comes to you and says, hey, I see you're looking at our code, what is this code doing? And your response normally is, that's what I'm trying to figure out, you shut up. And that's how we feel about it, very frustrated. But you can have a healthy conversation with them. Yeah, dude, let's talk about it. Given all the values from n, I'm getting all the prime numbers from n, I'm getting the square root of the values, but only k of them, and totaling them up. Is it what you really wanted? And it becomes really easy to execute the code as well. So it becomes very convenient to discuss about the code and interact with it as well. So to summarize what we talked about here, we went from a very cryptic code in this example to something very concise, but we are really able to use infinite streams and lazy evaluation. If you ask me, what is the big deal about functional style of programming? And I've been trying to struggle and learn about functional programming for a lot of time. And me included, a lot of speakers would tell you, oh my gosh, if you're doing functional programming, you should honor immutability. You should really not, you should use higher order functions. You should really focus on writing code like this. But I think those are, sure, important stuff, but that's not the real benefit or the excitement in functional programming. To me, the real excitement is all the functional purity and the programming with immutability, all that, where it is leading us is to this one exciting real feature, which is laziness. Because if you are lazy, both in life and in programming, the best people ever, most efficient people ever are the lazy ones. So you just say, hey, I'm going to postpone execution until I can no longer postpone it. And by waiting until that point, you can be really efficient. And that's what this code is showing us, how lazy evaluation can open up doors for not only runtime efficiency, but it can also open the door for things like infinite streams, which give us a programming tool that we very rarely exploit when we write code in Java, but this opens up doors for some really nice way of implementing things along the way. So essentially where this leads us to is we are able to express code in Java. This is kind of like, coming back to Java and being excited all about it one more time. And this is one of the things, honestly, that excites me, of all these decades later. Every single morning I get up to write code, and to me coding is not a profession, coding is an addiction. And to me the reason coding is exciting is being a programmer is like being a kid in a candy store every single day. And that's what really excites me, is to be able to write these kind of code and to be able to express them in ways that we just haven't had a chance to express in language like Java before, but we are able to do this, which is very, very powerful. So as you continue your journey on going from imperative to functional style of programming, to summarize things that can help you are, think about formulating the words in English. Ask the question, what am I doing? And that's a struggle we have to try a little bit harder. And when you formulate the problem in English and say, this is what I'm doing, then you start looking for methods that might closely match with your English description and maybe take on those functions and use it. The second part of that journey is, as you walk through the JDK libraries and functions, make note of functions you may not have seen before and take a look at, hey, this is interesting, I haven't seen this, what problem this probably is solving. That could be a really nice way to learn that as well. And a third thing I would strongly encourage is, I learn a lot by being critiqued. Going and sitting next to somebody and saying, hey, I'm writing this in functional style, why don't you take a look at what I'm doing? Maybe you have an idea. And even if they may not have an answer, just talking to somebody really helps us to untangle some of our brain, which is stuck in a particular comfort zone, and might open up ways to really think about solutions the way you may not have had a chance to think about. And that can be a really good learning experience, a shared learning experience as well. So that's basically what I have. Hope that was useful. Thank you.